I have wrote some codes with given instructions, and now I'm gonna explain you these codes line by line. Firstly, I have imported some things. These are Java util iterator, Java util linked list, Java util no such element exception, and last one is Java util queue. Iterator for making iterator, linked list for use to make a queue, and no such element exception thrown if we try to get an item that doesn't exist. And queue is interface for a queue. Here I have created a class named BinaryTree with generic type. And this is the start of a generic binary tree class that can hold any type T. Here we have private binary node T root. The root is the top node of the tree. And then we have constructor parts. The first constructor part is this constructor creates an empty tree with no root. And a second constructor is BinaryTree. And this constructor creates a tree with one node holding root data. And then last constructor part is for this constructor creates a tree with a root node, a left subtree which is left tree, and a right subtree which is right tree. And then we have public iterator get level order iterator. This is a get level order iterator method. And this method returns a new level order iterator. And here we have an inner class to create the level order iterator. It visits tree level by level. And then here private queue binary node T node queue. This is a queue that stores nodes while we visit them. And then public level order iterator node queue new linked list if root not equals null node key dot offer root. This constructor create an empty queue. If tree is not empty, put the root in the queue. And public boolean has next return node queue is empty. This method checks if there are more nodes to visit. And this is boolean, as you can see, it's gonna return true or false. Public T next. If has next, throw new no such element exception. If no more nodes, throw an error. Here binary node T current node not queue poll. This takes the next node out of the queue. These are, we have two ifs. And first one is if it has a left child, add it to the queue. Or if it has a right child, add it to the queue. and then return current node, get data. This gonna return the current node's data. Private static class binary node T. This is a inner class, a simple class to define a node in the tree. And as you can see, private T data, private binary node T left, private binary node T right. Each node holds the data, a reference to its left child, and a reference to its right child. Public binary node T data, this dot data data, this dot left null, this dot right null. Constructor sets the node's value and no children yet. As you can see, these are null. And we have some getter and setter methods for the node's data and children. Public T get data, return data. It's gonna return data. And public binary node get left child. It's gonna return left one. And then public binary node T gets right child. It's gonna return right one. Public void set left child, binary node T left. Is the setter method. And this dot left equals left. It's gonna set left with this keyword. This is as same as the first, the other one, fancy the left one, but you just change the left to right. Okay, that was all, and then I'm continue with the tree demo. Java. Firstly, I have imported Java LevelorderIterator, and then I just created a class named public class tree demo. And then here public static void main string args. This is the start of the main program. And here in these two lines, I just want to show you these two lines. In these two lines, I'm creating two small trees with roots B and C. The first one B and C. And then here, as you can see in this line, I am creating a full tree with A as root and B and C as children. Left child is B and right child is C. And in this line, iterator string level order tree get level order iterator. In this line, I am getting the level order iterator from the tree. And then these lines means while there are nodes left, print each node's data in level order. You see? And our code's finished. When we run this code, our result is this. Level order traversal A, B, C. This was our result. And then I want to explain you the time complexities of these methods that I have wrote. Time complexity analysis. I just wrote this as comment. First one is get level order iterator method. This time complexity is O1, and second one is level order iterator dot next, and its time complexity is O1 per node. and the whole traversal time complexity is O(n), where n is the total number of nodes. Okay, that was all. Thank you for listening to me. Bye.